Hi, and welcome back to Algebra 1. Our goal for today is to continue working with our solving equations and inequalities to a new type of equation called an absolute value equation. So how do we go about using our inverse operations to help us solve when we have absolute value bars and a variable inside of those bars? So the easiest, most simplified, most basic version of our equations for today are going to look something like this, where on one side of our problem, we have absolute value bars. Inside of those bars is our variable. Now, there might be additional stuff inside of the absolute value bars with our variable, but the variable in our equation has to be inside the bars, not outside. And when that's the case, how do we go about solving for the value or values that would create solutions or a true statement here? So you need to understand what those absolute value bars really stand for. So review from in our past, absolute values are really asking the question, if I were to count from 0 to the number that's inside of those bars, how far would we count? So in this case, we could think about this value of x inside of here could have a value of 20, right? If we said, if I counted from 0 to 20, we would get the value 20, right? So one option here is that x could equal 20. However, we have a second thing that x could be here. Now, remember, if I'm counting from 0 and I get to 20, I could go to the right of 0, 20, and end up at 20, or I could go to the left of 0, 20, and also count till I get to 20. So we now have a second option here, which is that x could also equal a negative 20. So instead of just getting one final value, we'll have two solutions, because inside of our absolute values, we can count from 0 to the right that number and get a value, or we could also count from 0 to the left on our number line that value. So when you're done solving these absolute value equation problems, you have to think about both possible options of what could be inside those absolute value bars, both the positive version of what could be in there and the negative version in there, right? If we took this negative 20 and we put it back into this equation up here, we said, what's the absolute value of negative 20? We would still get equals 20, and that's why it works. Now, you need to be careful because we could have something that looks very, very similar like this, where we have absolute value bars, and inside of those bars is a variable. And so right now we would say, oh, I could break this up, right? It has two options, right? 8 and negative 8. However, in this case, the answer, what it equals to part over here is a negative. And so what we need to remember is when we take the absolute value of a number, we can't get a negative. So this one's not possible, right? We can't get that as a result after taking the absolute value. So instead of taking this one and breaking it apart, right, we would say, oh, I can't break this one apart. I can't write two possibilities, right? I can't do this portion. And all I can do in this case is say that there are no real solutions, right? It's our special case when we have absolute value bars. Now, you need to be careful because some of our equations are going to have things that are outside of our absolute value bars and additional stuff on the inside of our absolute value bars, which makes the problems a little bit tricky. So we're going to look at all those different possibilities of how to solve. So our goal for today, how to solve when our variables inside of absolute values and we have an equal sign. So go ahead, take a second, fill in your steps. How do we solve absolute value equations? All right, you really need to think about your PEMDAS backwards as we navigate through these problems. When you're thinking about your inverse operations and solving when you have an equation, remember you always want to start with removing any adding or subtracting first. So when we get these absolute value bar problems, you need to remember that absolute values work like grouping symbols. So if which is way down here for letter P. So if outside your absolute value bars there's an add or subtract, you're going to use an inverse operation to remove that first. Then outside your absolute value bars, if there's some multiplication or division, you have to remove that second. And then you'll get down here finally to your absolute value bars. once you get to this portion where you have absolute value with some stuff on the inside of there, oh, excuse me. Let me get that back open. There you go, my fault. Once you get to where you have an absolute value equals and then a number on the other side, that's when you can take this inside and break it apart. It's just the absolute value portion of the problem that has two possible scenarios. All right, so let's look at example. Number one, we have the absolute value of y equals 17. All right, this is as simple and as easy as it gets. Our answer number is positive, so there are solutions. And all we have is absolute value with one single variable on the inside. When that's the case, I take that inside and I break it up into its two possibilities, right? Y could be a 17 or y could be a negative 17, right? That's as simple and as easy as it gets. So let's start to make things a little bit more complex. All right, number two, we want to solve here for the variable x when we're told that the absolute value of x minus 3 equals 5. Now, again, this is still fairly simple because on this side, we just have this absolute value stuff. There's nothing on the outside. And over here, we have a positive. So there are going to be solutions. So option one is that this entire inside, the whole x minus 3, could be two things. It could be 5 or it could be a negative 5. So we want to start with option one, which is x minus 3, right? That value in there can have a value of positive 5. Because if that x minus 3 has a value of 5, when we take the absolute value of it, we'll get 5. So we want to solve that. It's a one-step equation. So x minus 3 plus 3 equals our 5 plus 3. Cancel on the one side, we'll get x equals 8. Now the other option is this inside of x minus 3 could also have a value of negative 5, because if we were to take the absolute value of negative 5, we'd also get a 5. So it's also a one step where we'd have to add 3 to both sides of our equation to figure out what our other option for x is. So in this case, we get x would be a negative 2, right? So we have two options here. X can be an 8 or x could be a negative 2. Those would be the values we could substitute into that original equation to get either a 5 or a negative 5 inside of our absolute value bar. Two possible solutions here. All right, number 3. Again, fairly simple here because all we have on one side is absolute value by itself. There's nothing on the outside. However, this side, what it equals to is a negative. And we should understand that when we take the absolute value of something, we can't have a negative result. So this is not possible. So our final conclusion here would be there would be no real solutions for this one. So be careful, right? That's our special case that doesn't work. So be careful, right? This would be not equal to. It doesn't work. All right, let's look at one that's a little bit bigger, a little bit more complex. Now, be careful here. Those absolute value bars are just in the numerator portion of our fraction. Different than if the absolute value bars went around the entire fraction. So in this case, we want to get this absolute value part by itself. So working through PEMDAS backwards, we have to eliminate the stuff that's on the outside of those bars before we think about our two possible scenarios. The common mistake here would be to break it apart right now and say that that whole thing equals 5 and that whole thing equals negative 5, which is not true. Just this inside has two possibilities. We got to get rid of the outside part first, which means we have to get rid of this divide and this 8 before we do any thinking about the two possibilities for the absolute value portion of the problem. So we would need to remove a divide by 8 by multiplying both sides by 8. So we have our absolute value of a minus 5, which is being divided by 8, and we're going to multiply it by 8. We have this 5 that we also need to multiply by 8. On the one side, we're going to cross cancel, leaving us with our absolute value of a minus 5. On the other side, we would have a 40. Now that we have just this absolute value part left over, it's just this inside that could be two things. That inside could be a 40 or a negative 40. So we're going to break it apart and create our two problems. So we have an a minus 5 that can equal 40, which means we would do an a minus 5 plus 5 equals our 40 plus 5. Cancel on the one side, we end up that one of our possibilities here for a is that a could be a 45. Now this inside could have a second thing it could be, because a minus 5 could also be a negative 40, because when we take the absolute value of negative 40, it would also give us 40. So one-step equation again here, a minus 5 plus 5 equals our negative 40 plus 5. Cancel on the one side, we end up with a equals a negative 35. So two possibilities here. A can be a 45, or it could also be a negative 35. Okay, let's try another, number 5. All right, definitely bigger and more complex here. And there's a lot going on. I might want to put in here, I have a negative 3 plus 4 times absolute value of 2x minus 5 equals 1. Now, think of this problem if it were a little bit simpler like this. Negative 3 plus 4x equals 1. How would you solve to get this x by itself, which is representing this whole absolute value portion of the problem? Because you still have to do that part first before you think about how to break apart that 2x minus 5 portion of the problem. So we're working through PEMDAS backwards. Right? If we were to cover up our term that has the x, all we would see is negative 3. So we need to start by adding a 3 to both sides. So we have negative 3 plus 3, and then plus this 4 times absolute value of 2x minus 5. We do not distribute here. You're not going to distribute over those absolute value bars, so just be careful. And then over here we have a 1 plus 3. All right, cancel on the one side. We still have this 4 that's being multiplied with our absolute value of 2x minus 5. And over here we now have a 4. All right, we're still working through PEMDAS backwards. We're not ready to break anything apart yet because the absolute value part of the problem is not by itself. So we need to get rid of the multiply by 4 next. So absolute value, 4 times, the absolute value of 2x minus 5 is going to get divided by 4. And the 4 needs to get divided by 4. It'll now cancel over here on the side with our absolute value of 2x minus 5. And 4 divided by 4 will give us a 1. Now that the absolute value part is completely by itself, just this inside part can be two things, right? That inside could be a 1 or it could be a negative 1. So now we're going to break it apart into its two possibilities. 2x minus 5, no more bars here, right? We're pulling it out and thinking about what that inside could be. It could be a positive 1. Now we have a two-step here. So 2x minus 5 plus 5 equals a 1 plus 5. Cancel on the one side. We'll have 2x equals 6. All right, from there we have a 2x divided by 2 equals our 6 divided by 2, which would give us a x equals 3. All right, that's option 1. All right, I'll make my line a little bit bigger here. All right, option number 2 is we could have 2x minus 5 equals a negative 1. Again, that's a two-step problem. So 2x minus 5 plus 5 equals our negative 1 plus 5. Cancel on the one side. We still have 2x. Negative 1 plus 5 would give us a 4. Then we're going to take our both sides and divide by 2. And we'll end up that x could equal 2. So x equals 3 or x could equal a 2 would be our final solutions here. Be extra careful. You have to remove anything outside of the absolute value bars before you do any breaking up. Once you get to this step right here, if this number is negative, that would be your special case of no real solutions. If it's positive, you need to break it apart and find your two possible solutions. All right, I hope this helps you attack your work for today. See you guys later.